So I want to give you some quick video recording on, let's see, line reflections. So what I did was I grabbed Geometer Sketchpad, and we're going to take a look at some different things that are going to happen, some key concepts. So first, what this is going to be is I'm going to mark this as the line that we're going to reflect over, okay? And you'll see the different views here. This is the figure that I'm going to go ahead and reflect. Let's start with a line that's more straight up and down. This is probably more of what you're used to. Okay, if I placed it like this. All right, so if I grab this and I reflect over the line, okay, we're going to label that reflection with primes, which you guys have seen that, show labels. Okay, so the point A right here turned into A prime. C right here went to C prime, and so on. Now, a couple of things that we have to talk about. If you look at this right here, if you were to construct a segment joining point A with its image, here's what we would notice. From here to here is going to be identical to from here to here. Okay, so what that's going to show in a minute when I talk about what's the property that this line has with the segment that joins a pre-image to its image. Okay, you can kind of look at it. Now what we'll do is we'll take a look, we'll mess with the line. That property is still happening. Basically, the mirror or the line of reflection ends up being the perpendicular bisector for any A to A prime, any pre-image to image segment. Okay, so same thing's going to happen here if you look at B to B prime. Okay, you can tell that this line is perpendicular to the segment joining B and B prime. It's also, if you look, you can see this right here. Okay, that segment's going to be the same as the segment from here to B prime. So that's the property that you have to really understand to be able to fully understand what line reflections do. So let's go over to the notes. Okay, so back to the notes of this. So what we're trying to do is make sure students understand this. The line of reflection, this is the big concept. The line of reflection must be the perpendicular bisector for any pre-image to image segment. Okay, so if you know the line of reflection, which we do here, what we would have to do is you could construct this. This is what we eventually will have to do. What you would construct, and I'm not constructing it right now, I'm guessing, what you would have to construct is a perpendicular and a perpendicular line the same distance away from the mirror. And that's where A prime is going to land. Same thing if we could estimate where this perpendicular is and go the same distance from here to here, should be the same as from here to here. Okay, that's where B prime would land. So if you understand that perpendicular bisector concept, you're going to be able to find the image, right? You're going to be able to find the image given the line of reflection, or there's another option that we'll be able to do as well, where if I give you the pre-image and image, you'll be able to construct the perpendicular bisector, which is to find the line of reflection. Okay, so this is going to give us the big information that we need. All right. Okay, and then I went over and I actually had Geometer Sketchpad do it. It's a lot better. So that's where A prime lands. Okay, A to A prime. This line of reflection is going to be the perpendicular bisector of that, and that's what I was showing. This is going to be C prime, again, right, perpendicular, and bisect the double lines. That's because it may be different than this one. So I can't use a single slash, but I do want to show that these halves are the same. And then the last one, of course, is this one. Okay, perpendicular, and I'm going to use a triple mark, showing that those are the same. That's B prime. Okay, so again, use that concept of perpendicular, and you'll be able to do a lot with this. All right. Okay, so let's try some homework problems right out of the packet, and that way I can demo it. It's only a few of them. You're going to have to do the rest on your own. And so let's go through this. I just picked number 4 from page 3 on our homework packet, and I want to explain some notation, which we went over in class. If we have the notation, the symbolic notation, lowercase r, y equals -3. There's a lot going on. The lowercase r means reflect. Now, sometimes we reflect over a point, sometimes it's a line. When it has a subscript, which they all do, a subscript is lower to the right, smaller. That's going to tell us whether it's a line or a point. Now, a point will look like this, say -2, 9. You know, that means we're going to reflect over the point. That's not what's here. We've got this y is -3 deal. Well, what we have to know is that that is a full-on line. So that means line reflect. Our mirror is, or line of reflection, whatever people want to call it, is y equals -3. So what I would want you to do with your straight edge is go ahead and graph y equals -3 right here. Okay? So you're going to graph your mirror. All right? Now we're going to take each point, use the concept that the mirror is the perpendicular bisector, to find the missing point. So if this line is the perpendicular bisector of t to t prime stays there. It's right on there. So I'm going to list that. T prime stays at 3, -3. It's the same point as the pre-image, so it's an invariant point. So when a pre-image and an image are identical, same location, we call that an invariant point. It does not move. Okay? Just for that simple line reflection, because it is on the line of reflection. So that's something that will come up. All right, let's go through this. So if this point is R, right, and it is 1 away from the mirror, it's going to go another one. That's going to be R prime. And then that location looks to me like it's 1, 2, 3, 4. It looks like 1, -4 is going to be P or R prime. I'm sorry. R is not finishing. And then S prime. Okay, that's up here. 1, 2, 3, 4 away. 1, 2, 3, 4 away. Now this seems really easy, these line reflections, and I'll explain in a minute why they are. 1, 2, 3, 4, and negative, looks like -7. Okay, so these look really easy, and this is why. Because when you have a horizontal line, a vertical line is a perpendicular path. So what we've been doing in most of your experience with line reflections is we've been counting either straight up and down, following a path that's already pre-designed, or straight across to do this counting. So you've never really had to experience anything with perpendicular, slopes that are negative reciprocals. So it's been very easy. Okay? Now we get into the tougher problems, and here's where this comes into play. If we want to reflect over the line y equals x, okay, first of all, the notation, that's a line reflect. Okay, the mirror is going to be y equals x. It's not a point, so we knew it wasn't a point reflect. So this is actually a line equation. All right, so here goes. Use your straight edge. This is the line y equals x. This is something you have to memorize. Okay, talk to your teacher about this if that doesn't make sense. And what we're going to do is, this is where it gets tricky. Okay, I'm going to use a different color. I need to explain to you why we can't just use one of the current paths. We can't just count along a path straight across. We actually have to count a path. We have to create a path that is perpendicular to this line. This line has a slope of up 1, right 1. Well, what do we got to do then? From I, if we want to reflect over this line, we're going to have to use a slope that is down 1, right 1. Okay, so this path is going to look like this. That is the path that's going to be perpendicular to the mirror. Okay, so a perpendicular path or line has to have a slope that is down 1, right 1. I'm going to have to do that with all the points. Okay, J. I'm going to have to use this path. Okay, so this is the path I'm going to use for J. It's going to be a perpendicular path. Now, you've got to trust me on this. Okay, draw the path first. Draw the path, the image. We'll move along first. Do not try to just figure out where that location is. Students make a lot of mistakes when they do that. This fixes those mistakes. Draw the path first. We'll worry about the distance after. Okay? After the path is drawn, then get the distance correct. And I don't care how you get the distance correct. Some of my students count the diagonals, and that's great. Okay? So for I, it's a half of a diagonal away from the line, so right there is I prime, a half a diagonal on the other side. J is 1 1/2 diagonals away from the mirror. There's the half, there's 1, that's J prime. And H, I never drew the path for. First the path, it's down 1, right 1. So here is, you got to be really careful. Here's the path that H is going to follow. Use your straight edge. Okay. And it's 1, 2, and 3 full diagonals away from the mirror. So we got to go 1, 2, and then that's the third one. This is where H prime will land. Now, when you first do this, okay, it's not going to look right to you at first. Okay, it certainly doesn't look right to me. Oh, whoops, that's because I missed. That's better. All right, let me get rid of those last two. Yeah, that wasn't the right point. Get rid of that one. Okay, so that looks a lot better now. Okay, so let's take a look. What were the coordinates? So if we go with H prime, it landed at 3, -3. All right, we're looking right there. I prime went to 2, 1, and J prime went to 1, -2. All right, I am doing a little cheating there, and this is important. I do want you to memorize this. When reflecting over line y equals x, we should just switch the coordinates. That is something that is not really a math cheat. It makes it faster for us. We don't have to do all this stuff that I'm talking about, but it is something that we're going to do next year in math when you hit Algebra 2. So I might as well teach you now. It's useful. So that's the only time we're going to switch the coordinates. Here's the algebraic notation of that. You know, a coordinate xy is going to turn into yx. Okay? So when I was doing this problem, I had something like h. H was at -3, 3, right? So then H prime, after reflect over y equals x, I didn't even really look at the graph. I knew it was going to be 3, -3. Okay, for I, we'll do one more. It was 2, 1. I knew I prime was going to be 1, 2. Whoops, the other way around. My fault. Sorry. Let's do that. I was 1, 2, so I prime was 2, 1. All right, and so on. But that's only for y equals x when we reflect over that line. Last one. This one, that trick won't work because it's y equals -x. Okay? Now that's this line. Y equals -x is this diagonal. It comes this way. There's the line. Sorry, I can't get a straight edge to work on this. Okay, but that's the line y equals negative x. Okay, so it's this path right here. It's hitting these diagonals. Basically, your y-intercept is 0, and it's down 1, right 1 for a slope. Well, how do we do this? How do we reflect over that line? Start with u. If this has a slope of negative 1, I have to travel up 1, right 1, okay, to get where u is going to. So u is going to be somewhere on this path right here. U is going to be somewhere on this path, u prime, somewhere on this path. What happened? Sorry about that, the touch screen again. Let's go back to, all right, so now I'm looking at V. I got to go down 1, right 1. I'm sorry, up 1, down 1, left 1. That's going to be a slope of 1. So somewhere along there is the path for V prime. Same thing here. This is the path for W. W is going to be somewhere on this path. How far? Now we'll go get the distance. Okay, for W, it's 1.5 diagonals. Okay, there's the half, and then there's 1. There's W prime right there. Okay, V looks like 1.5 diagonals as well from the line. So there's your half, and there's 1, V prime. And what was the last one? Okay, U. U is a half of a diagonal away on this side. So that's where U prime is going to end up. Okay. So it's going to look like there's V prime. It's going to be right there. Okay, that's what it's going to look like. A little bit of overlap. All right, so U prime, where is it? Should be, let's see, should be -1, 2. V prime should be -4, 1. And W prime should be -2, -1. So let's make sure that that actually happened. Yep, that's W, good. And everything worked out the way it was supposed to. Good. So that's a couple of problems that were tougher on the homework that I wanted to cover for you. I know, sorry, this was a longer video than I anticipated, but check it out. Make sure you can do the problems on page 3, and I'll put up another one here in a minute.